Hello, this is Ms. Skokin, and we're back in Chapter 1, Foundations for Geometry. We're going to be talking today about Section 1-6, Midpoint and Distance in the Coordinate Plane. We'll start off by taking a look at the objectives, develop and apply the formula for midpoint, and use the distance formula and the Pythagorean Theorem to find distances between 2 points. Our vocabulary includes coordinate plane, leg, and hypotenuse. And if you remember, the coordinate plane is where we graph on an x and y axis. And the leg and hypotenuse are terms for the sides of a right triangle. Remember that as you're watching any of the lesson videos, whenever you need to stop the video so that you can write something down, go ahead and do that. We have a warm-up, and we're going to take a look at each one of these questions separately. The first one says, graph and label points A and B. Remember that both the x-axis and the y-axis are number lines, and on the left, or going towards the left, we go towards the smaller numbers or more negative numbers, and as we move towards the right, we go to larger numbers. So the points A and B, the first coordinate is the x-coordinate, and the second coordinate is the y-coordinate. In order to locate point A, we're going to go to -2 on the x-axis, and then we're going to go to +3 on the y-axis. We're going to label our point that way. To find B, we're going to go 1 in the positive direction on the x-axis, and then we're going 0 in the y direction, which means it's sitting right on the x-axis. Our next question, question 2, is asking us to find CD. That's what we read it as, but really what that means is find the distance between points C and D on the number line. We might be tempted to do what we used to do, which is count jumps, and if we did that, we would need to pay attention to the scale, because in this case, this number line is scaled by 2s, and we would have gotten the question wrong if we would have answered 4. It would have to be 4 jumps times 2 to give us a distance of 8 between -6 and 2, or between points C and D. There's another way that we can look at this, though, and we can say that the distance between C and D is the difference between our coordinates, and this is always a sure thing, so I definitely recommend doing this. Now, when we say difference, remember that means subtraction. So we would say 2 minus -6, or the distance between points C and D is +8. Remember that distance is always going to be positive. And let's move on to number 3. I know what you're thinking. You might say, wait a minute, this is the same number line that we had on number 2, and you would be correct. This time, though, it's asking us to find the coordinate of the midpoint of segment CD. And that means exactly in the middle. The middle is the point that is exactly in the middle of the other 2 points, C and D. We're looking at this on a number line right now, but if I said to you I wanted to find the midpoint between the ages of someone who is 8 and someone who is 12, you would know exactly how to do that. You would find the average or the mean between those 2 numbers, and that's exactly how we're going to find the midpoint. We're going to say that the midpoint, or the halfway between point, is going to be the average of the 2 coordinates, -6 and 2. Remember that in order to find the average, we add the numbers together and we divide by the number of numbers that we have. In this case, when we add -6 and 2, we get -4, and then we divide by 2, giving us a midpoint of -2. That brings us to question number 4. And here we have a radical expression. It says to simplify the square root of the square of the difference between 3 and -1. Just a quick reminder that the radical symbol, or the square root symbol, is a grouping symbol, just like parentheses, braces, brackets, absolute value bars. And another reminder that no matter what we're doing when we're simplifying, we're going to follow the order of operations. 3 minus -1 gives us 4, and then we notice, we're going to save a little time here, because the square and the square root are inverses of one another, and they will cancel each other out. And that means that the square root of 4 squared is just 4. Now let's take a look at our box with the midpoint formula. We were looking at a midpoint just a few minutes ago when we were looking at question number 3, and that was on a number line, and in order to find the midpoint, we found the average of the two coordinates. This is going to be no different. This time, though, we're doing it in the x direction and the y direction separately so that we can get the x coordinate and the y coordinate of the midpoint between any 2 points. So our midpoint formula box says the midpoint M of segment AB with endpoints, of course, x and y coordinates, is going to be found by averaging the x coordinates to find the x coordinate of the midpoint and averaging the y coordinates of points A and B in order to find the y coordinate for the midpoint. The formula looks more complicated than it is, and hopefully you'll remember when we go on to example number 1, which is next. Example number 1, finding the coordinates of a midpoint, says, find the coordinates of midpoint of the segment PQ with the endpoints P and Q. We definitely do not need to graph points P and Q to be able to find the midpoint, but let's just get a general idea of where they are on the coordinate plane. Here we've got a rough little sketch of segment PQ on the coordinate plane as well as the midpoint M. We'll call it M, we don't have to, but we will. And let's go ahead and get started using the formula now that we have an idea of where it should be. First things first, let's write down the formula for midpoint. As we look at the midpoint formula, we remember we're taking the average of the x coordinates to get the x coordinate of the midpoint, and we're taking the average of the y coordinates to get the y coordinate of the midpoint. Let's label the coordinates of points P and Q so that we can plug into our midpoint formula more easily. Okay, we've got the formula, we've got the numbers to plug into the formula, let's plug in. -8 plus -2 gives us -10, and 3 plus 7 gives us 10. So we know that we're going to end up with a midpoint location of -5, 5. And that is how we find the midpoint of segment PQ. Let's take a look now at example number 2. This is finding the coordinates of an endpoint. So that sounds a little bit different than what we just did. It says M is the midpoint of segment XY, and X has coordinates 2, 7, and then M, the midpoint, has coordinates 6, 1. Find the coordinates of Y. So what they're asking us to do this time is not find the coordinates of the midpoint, but instead find the coordinates of one of the endpoints of the segment. And again, we don't have to do it, but giving ourselves a little sketch gives us an idea of roughly where point Y should be. This is not going to be a problem for us because we have the midpoint formula. The only difference is where we're plugging things in because we were given different information. So let's first write down our midpoint formula. Usually we write down the midpoint formula together as a coordinate pair, and the way that we did in the previous example, but since we're given different information this time, we're going to split up the coordinates, the x coordinate and the y coordinate. We know that the x coordinate of the midpoint that was given to us is 6. And we also know that point x, the x coordinate, is 2. What we don't know are the coordinates for point y, so we're just going to put in an x for that one, and then divide by 2 in order to find the average. Now, we know how to solve this algebraically. The first thing that we're going to do is multiply both sides by 2 to get rid of that 2 in the denominator. Those are going to cancel. We're going to have 12 is equal to 2 plus x, and x is equal to 12 minus 2, or the x coordinate of point y is going to be 10. All right, we found one. Now we just need to find the y coordinate. We're going to set that up exactly the same way. Starting out with our midpoint formula for the y coordinate, and then we're going to plug in. The y coordinate of the midpoint is 1, and then we're going to put in the y coordinate for point x, which is 7, and we're just going to put in a y for the one that we don't know, which is point y. So we've set it up as the average once again. Again, we're going to multiply both sides by 2 so that we can solve for y, and we find that y is equal to -5. Okay, we have found both the x and the y coordinate, and now we just need to put it into a coordinate pair for point y. Because our final answer for this question does need to be in the form of a coordinate pair, that's what we were looking for, the location of point y, one of the endpoints of segment xy. So there we go. Let's just check and make sure that that looks reasonable based on the little sketch we did earlier. And it does. 10, -5 is about where we would have expected point y to be based on the sketch we did earlier. Okay, well done. Let's move on to the distance formula now. We can use the distance formula to calculate the distance between any 2 points in a coordinate plane. And another way to look at that is we can use the distance formula to find the length of any segment in the coordinate plane. We see the distance formula in the box, and it's the difference between the x coordinates squared plus the difference between the y coordinates squared, and then we take the square root of that. Let's try it out on example number 3. Example number 3 says we want to find the distance between points F and G and the distance between points J and K. Then we're going to compare them and see if those two are congruent, if those two segments are congruent to each other. So let's start out by writing our distance formula. Just to make the plugging in a little bit quicker when we are plugging into our distance formula, let's go ahead and write down the coordinates of our 2 points. Point F is located at 1, 2, and point G is located at 5, 5. Now let's plug into the distance formula. Let's work through the numbers. 1 minus 5 is -4, and 2 minus 5 is -3. When we square -4, we get 16. When we square -3, we get 9. And we're going to end up with a square root of 25, which is 5. So segment FG is 5 units long. The next step is to find the length of segment JK. And once again, we're going to plug our points into the coordinates of our points for J and K into our distance formula. So once again, let's put the coordinates down. K is located at -1, -3. That's a little bit hard to read. And then point J is located at -4, 0. Plugging into our formula, we have -4 minus -1, and we've got 0 minus -3. -4 minus -1 is going to give us -4 plus 1, so that's -3, and 0 minus -3 is going to give us 3. -3 squared is 9, 3 squared is 9, so we're going to end up with the square root of 18. And we already know that these two segments are going to not be congruent because the square root of 18 can be simplified as 3 root 2, or if we put it into our calculator, we end up with about 4.24 units. And that is definitely not equal to 5. So for a final answer, we're going to say segment FG and segment JK are not congruent, which is the question to the answer, or to the answer to the question we were originally asked. All right, let's now take a look. Let's take a look on the next page where we're going to be talking about the Pythagorean Theorem. We can also use the Pythagorean Theorem to find the distance between the 2 points in a coordinate plane, and basically what we're going to do is we're going to turn any diagonal segment into a right triangle. In a right triangle, we remember that the hypotenuse is the longest side and the one that's across from the 90-degree angle. The other two sides are called legs. And we have the Pythagorean Theorem formula, which says that the sum of the squares of the lengths of the legs is going to be equal to the square of the length of the hypotenuse. And that's what it says inside of our box here. So let's take a look at example number 4. Example number 4 says use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from points D to E. Let's start by graphing points D and E. Once we've got those 2 points graphed, we're going to draw the segment between them. Now we're set up to be able to use the distance formula. Here's our distance formula. Let's go ahead and plug the value or the coordinates in for points D and E and calculate the distance. Pause the video while you do that. We find that the distance between points D and E using the distance formula is approximately 10.3 units when we round to the nearest tenth. Now it's time to try out the Pythagorean theorem. So the first thing that we need to do is to make our right triangle. We've got our right triangle now, and we need to calculate or determine the distance between the point E and this right angle and point D and that right angle. So we're going to count how many units it is, and we have 5 units in this direction. And in this direction, when we count, we find that we have 9 units. So remember that either one of the legs can be either one of these sides. I'm just going to arbitrarily pick side A to be this direction and side B to be this direction. We know side C is always the hypotenuse. Now we're ready to set up the Pythagorean theorem. We're going to start with our equation, our formula, c squared is equal to a squared plus b squared. And just remember, we don't really want c squared. We don't want the square of the length of the hypotenuse. What we really want is c. So what we're going to do is take the square root of both sides. So that's going to give us c on the left, and it's going to give us the square root of a squared plus b squared. When we plug in, that gives us 5 squared plus 9 squared, which should look familiar because we just did these same numbers with the distance formula. So we realize that we are going to have the length of the hypotenuse when we round it to 1 decimal place of 10.3, just like we did with the distance formula. So you can see how closely these two are related and how we get the same answer either way. So they're basically the same thing, the same tool. Let's take a look at a real-world example now. We are on a baseball field. So let's read the question. The 4 bases on a baseball field form a square with 90-foot sides. A player throws the ball from first base to a point located between third base and home plate and 10 feet from third base. So that means that the point that we're throwing to has got to be right here. So we're throwing from first base to this point that we've marked. The question then goes on to ask us, what is the distance of the throw to the nearest tenth? So I say we use the Pythagorean theorem and we make a right triangle out of this. The first thing that we need to do is draw our triangle, so I'm going to start with a segment between the 2 points. This segment is going to be our hypotenuse. I've shaded the triangle in just to make it a little bit easier for us to see where our right triangle is. We know our right angle is at home plate. The next thing that we need to do to be able to use the Pythagorean theorem is determine what the lengths are of each of these sides. And across the horizontal, the length of this one is 90 feet long. And the vertical direction, or from home plate to the place where the player threw the ball, is 80 feet long. So those are the numbers that we're going to be using in our Pythagorean theorem. And just as before, it doesn't matter which one we call A and B, so we'll just choose, and we'll say A is the 80-foot long length, and B is the 90-foot long length. And remember, eventually we're going to want to square root both sides because we're interested in the distance of the hypotenuse, or the real-world version is how far the ball was thrown, not the square of how far the ball was thrown. So we continue on with our calculation. We end up needing to find the square root of 14,500, and that is going to give us, when we plug it into our calculator, to the nearest tenth of 120.4 feet, and that's how far the ball was thrown. At this point, we are finished with our lesson and we're going to move on to our practice problems. If you have any questions about anything that we've gone over during this lesson, please write them down directly into your notes and let's discuss them in class.